Hello everyone. In this video, I want to talk about how logistic regression analysis works. Please note that this is a lecture that talks about the mathematical principle of a logistic regression analysis. If you want to see how to implement this analysis in the R software, I listed the video in this video's description section below. You can watch that video to see how you implement the analysis in the R software. But this video is just trying to help you to understand the mathematical principle behind the logistic regression analysis. In this video, I will also use two example data sets. I listed them under this video's description section below as well. If you want to practice the data analysis, please download the dataset in this video's description section. Let's talk about how a logistic regression analysis works. I want to use an example to show you. An entertainment analyst wants to predict the probability for a movie to win an Oscar award. His assumption is that the more nominations a movie receives, the more likely it is for the movie to win an Oscar. Let P denote the probability for the movie to win an Oscar, and X denote the number of nominations the movie receives. Therefore, we can get a linear regression model, P equals to B sub 0 plus B1 times X. We just need to form a data set and then use a data set to estimate the value for B sub 0 and B sub 1. And then we are able to build a linear model, right? Let's take a look at the data set. In order to validate his assumption, he collected the winner of Oscars and how many nominations the Oscar winners received from the year of 1984 to 2007. I recorded the values for the independent variable X in the C column. As you can see here, I recorded the number of nominations each movie received. In the D column, I do the following. If a movie received no Oscars, then I will record 0 for that movie. If a movie received 1 or more Oscars, then I will use value 1 for that movie. Please note that the values 0 and 1 in the D column are not the values for the dependent variable in our linear model, because in our linear model, the dependent variable is the probability for a movie to win an Oscar. 0 and 1 are obviously not the values for the probability. They just help us to build a linear model to predict the probability for a movie to win an Oscar. Please pay attention to this key feature. Some classmates may have a question. What if a movie won 2 or 3 or even more Oscars? Do we still use value 1 for that movie? The answer is yes, because our linear model is to predict the probability for a movie to win an Oscar. Yes or no, right? The probability for yes or no answer to the question of if a movie can win an Oscar or not. We are not trying to predict how many Oscars a movie can win. So no matter how many Oscars a movie won, as long as the movie won at least 1 Oscar, we use value 1 for that movie, not 2 or 3 or even more. Please pay attention to the second key feature. We have 2 ways to build the linear model. The first way is to use the data visualization function of Excel. By the way, using Excel is just for the instructional purpose. You can use other software to build the linear model as well. For the instructional convenience, I use Excel in this lecture. You can use R. You can watch the other video I created. In that video, you use R to calculate the probability. Let's see how we find the linear model in Excel. First, we need to select a range from C1 to the last cell in the D column. Select this range. And then I want to click the Insert tab on the top. And then I'll go to Scatter button. Click the little triangle over Scatter, and then choose the first scatter chart. This is the visualization of the linear model between dependent variable and the independent variable. Each blue dot represents the observation in our data set. If you move the mouse over the first blue dot, that means that movie won an Oscar, and that movie received, as you can see, received 5 nominations. If you move the mouse to the second blue dot, you can see that movie also won an Oscar, and that movie received 6 nominations. We don't have to click on the blue dot, just move the mouse over it, you will see the value this observation dot represents. How can we build the model? It's pretty easy. Let's click on any of the blue dots, any one of them, and then right click on the chart, and then choose Add Trend Line. Add Trend Line in the pop-up menu, and then in the Trend Line options, go to the bottom of this option, and then check the box before Display Equation on Chart, and then click Close. Now we get the mathematical relationship between the independent variable and the dependent variable. According to this equation, you can see that y, which is p in our equation, right? P equals to 0.08 times x minus 0.405. This is the relationship between the number of nominations and the probability for a movie to win an Oscar according to our current data set. I have already copied this equation in the PowerPoint, so let's go back to the PowerPoint to talk about the relationship. This is the model we get from our data set and the Excel analysis. It seems reasonable, but the colleagues of this entertainment analyst questions about this equation. She said, what if a movie receives 2 nominations this year? Can we use this model to predict the probability for that movie to win an Oscar? If we use the current equation we built, we replace x with value 2, then we'll get a result as you can see on this slide. The probability according to your current model is negative 0.23, or if you round the number, it will be negative 0.24. It doesn't make sense at all, because the probability can only be a value between 0 and 1, including 0 and 1. It could be 0.12, it could be 0.33, but a probability can never be a negative value. So what should we do? We need to do 2 transformations on the dependent variable part in our linear model. First, instead of predicting the probability for a movie to win an Oscar, we predict the odd for that movie to win an Oscar. Here we meet a new concept, an odd. What is it? It is a ratio between the probability of the events you want to happen and the probability of the events you don't want to happen. Let's say we predict the probability for a mediocre movie to win an Oscar is just 10%. What should be the odd for that movie to win an Oscar? Let me give you about 30 seconds to think about your answer, and then I will share the answer with everyone. The answer should be 1 over 9. Because this question is so simple, I cannot wait to tell you the answer. Why? Because the probability for that movie to win an Oscar is 10%, right? What is the probability for that movie to lose an Oscar? 90%. Then what should be the odd for that movie to win an Oscar? According to the definition of an odd, it should be 10% over 90%. Finally, we get 1 over 9. Let's say we predict the probability for another movie to win an Oscar is 60%. What should be the odd for that movie to win an Oscar? it should be 6 over 4. If you divide 6 by 4, then you get 1.5, right? Why we get 6 over 4 first? Because the probability for that movie to win an Oscar is 60%. The probability for that movie to lose an Oscar should be 40%. Then the odds for that movie to win an Oscar should be 60% over 40%. Finally, we get 6 over 4. And then we can divide 6 by 4. It will give you 1.5. Why do we want to do the first transformation? Why do we want to predict an odd instead of a probability? The two examples I just gave everyone kind of answered this question. As I said, the odd for the first movie to win an Oscar is 1 over 9, which is 0.11. That number is between 0 and 1. The odd for the second movie to win an Oscar is 6 over 4, which is 1.5. What does this mean? That means an odd can hold any value. Less than 1, equals to 1, greater than 1, doesn't matter. If we look at the linear model, the left side of the linear model represents the odd. That means the left side can hold any value now. We break the limitation for the right side to give us a value that must be between 0 and 1. What is the right side so far? We already get the right side from the Excel analysis, right? It is negative 0.40 plus 0.08 times x. Suppose we get the nomination for a new movie. That movie received 20 nominations this year. That movie had a fantastic performance. We replace x with 20. Then we use 20 times 0.083. We get a value 1.66. 1.66 minus 0.40. We get a value that is around 1.26. If we give 1.26 to p directly, that doesn't make sense because p can only hold the value that is between 0 and 1. However, if we give 1.26 to the odd, to the left side of the linear model, it makes sense now because an odd can hold a value that is greater than 1. Then we give the value 1.26 to the odd, p over 1 minus p, to calculate what p-value is exactly. With the transformation, we can allow the right side of the linear model to give a value that is greater than 1 to the left side of the linear model. But our model is not perfect yet. Sometimes the right side can give us some negative value. Just like the example we talked about at the beginning of this lecture. If a movie just receives 2 nominations, the result for the right side will be negative 0.24. If we give this value to p directly, it doesn't make sense. What if we give 0.24 to the odd? Does it make sense? It doesn't make sense either, because an odd can only be a positive number. It cannot be 0, it cannot be negative number. So how can we accept the negative number on the left side? Instead of predicting an odd, we predict the logarithm value of the odd. Now the left side can accept negative numbers. Why? Because we give the negative number to the logarithm of the odd, not to the odd or to the probability directly. The second equation makes more sense now. But how can we calculate the value of p in a logarithm form? Some classmates may already found the solution. We need to give both sides of the linear model as the power of the natural number e, just like what you see in the next slide. This is a very important transformation we need to do. because according to the inverse rule of a logarithm, the left side will be p over 1 minus p. As long as we take the odd out of the logarithm form, the followings are just the basic algebra calculation. Finally, p equals to this one. Some classmates may say, I'm familiar to the last equation. This is exactly what we used in the R lecture. That's right. This example shows everyone the building process of a logistic regression model. In the future, no matter which software you use, Excel, R, or other software, when you get the values for b sub 0, b sub 1, b sub 2, and so on, you must use the last equation we get here to do the transformation. In our case, we get negative 0.4 as the value for b sub 0. We get 0.08 as the value for b sub 1. We need to plug in these two numbers into the final equation in order to calculate the probability for a movie to win an Oscar. Let's say we already know a movie receives 2 nominations. Then according to the transformation equation we get, we can predict the probability for that movie to win an Oscar is 0.44. Let's see another example, just for a practice purpose. The entertainment analysts want to build another logistic regression model to predict the probability for a movie to win an Oscar. Now he has several independent variables. He uses x sub 1 to represent the number of nominations the movie receives, x sub 2 to represent the number of Golden Globes the movie receives, and x sub 3 to represent if the movie is a committee or not. According to what we just discussed, we must use the equation as you can see on this slide to calculate the probability for something to happen, for a movie to win an Oscar. So as long as we know the values of b sub 0, b sub 1, b sub 2, and b sub 3, we are able to calculate the probability for a movie to win an Oscar. How can we calculate those values? Let me show you. This is the second data set I'm going to use. It's called Oscars. The independent variable values are recorded in the C, D, and E column. And then in the F column, I use 0 to indicate a movie didn't win an Oscar. I use value 1 to indicate a movie won an Oscar. I just showed you how to use data visualization, how to use the scatter plot to find the mathematical model. But that method can only be applied to a case with only one independent variable. If you have 2 or more independent variables, you have to use the second way. Now let me show you. Let's click the Data tab on the top, and then click Data Analysis. And then in the pop-up menu, you want to choose Regression, and then click OK. For the Y range, you want to choose the values in the F column, from F1 to the last cell in the F column. It's F172. And then click the Confirm button. And then for the X range, you want to choose where the independent variable values are, from C1 to the last cell in the E column. And then click the button to confirm. Next, we want to check the box before labels, because the first row holds the titles of the columns. And then we want to click OK. Now you can find the result from the Excel analysis. I already copied the results into the PowerPoint. So let's go back to the PowerPoint. This result shows several important information to us. First, we need to look at the numbers under coefficients column. These numbers. These are the values of b sub 0, b sub 1, and so on. Corresponding to intercept, we have negative 0.249. This is the value for B sub 0. Corresponding to Oscar nomination, we have value 0.046. This is the value for B sub 1, and so on and so forth. We need to plug in these numbers into the logistic regression model, and then we get this equation. In the future, if we find a new movie have certain number of nominations, Golden Globe Awards, and if it is a committee, we can plug in those numbers into x sub 1, x sub 2, and x sub 3 to predict the probability for that movie to win an Oscar. Let's say a new movie receives 10 nominations, 3 Golden Globes, and it is a committee. Then we replace x sub 1 with 10. We replace x sub 2 with 3. And then we give value 1 to x sub 3 because it is a committee. If it is not a committee, then we give value 0 to x sub 3. By doing this, we can calculate the probability for that movie to win an Oscar. Also, we need to pay attention to the p-value here. These p-values are used to evaluate if an independent variable is a significant influencing factor. If the p-value for an independent variable is less than the level of significance, then we can say that independent variable is a significant influencing factor. You can also look at the r-squared value here. It's 0.3145. This means if the probability for a movie to win an Oscar changes by 1 unit, changes by 1%, then about 31.45% of this 1 unit change can be explained by the independent variables you select. This is how you perform a logistic regression analysis.